Hey everyone, this is Mr. Allers. It's April 20th. I'm just getting a head start for week 14, 427 to 5-1, almost to May. I think we have like 6 weeks including this week to go. So we'll get started. This is your PDN for 4.4.2. Hope you're all doing well. And 2, 3, and 5. All right. So a rectangular prism is cut along the shaded plane drawn below. Draw the shape of the cross section. So I think that's the cross section. So it's going to be a triangle. Andrew has a piece of foam. The shape of a rectangle prism shown below. The base is a square with sides 3 inches long and a piece of 5 inches tall. He cut the foam on diagonal shown by the shaded area. Find the exact area of the cross section. So this is 3. And then this is 5. Call this C. And then this is 3. So we're going to do 3 squared plus 5 squared equals C squared. 9 plus 25 equals C squared. C squared equals 34. C equals the square root of 34. This is the square root of 34 times 3. So the area is 3 root 34 inches squared. Find the exact perimeter. So that's 3 plus 3 plus square root 34 plus square root 34. This is 6 plus, and then when you add these, you keep them, and then you put a 2 because you have 2 of them. What is the length of diagonal of the cross section? So now we're going to use Pythagorean's theorem again. Square root 34 squared plus 3 squared equals C squared. 34 plus 9 equals C squared. 43 equals C squared square root. C equals the square root of 43 inches. And this is inches. There you go. My weekend highlight is I guess I went to I don't know what I did this weekend. I guess because it hasn't happened yet for me, so I can't tell you. There we go. Moving on to 4.2.2. Talking about geometric solids. Take a look at the picture right, showing the computer graphic artist's conception of Project Orion's spacecraft. What geometric shapes are used to create the artist's spacecraft? So I see cylinders. I see rectangular prisms. Nope, not rectangular prisms. Cylinders, I see cones and spheres. I know this was filled out. This was a triangle. I'll go back and fill that in. So we had cones, cylinders, and spheres. Geometric solids are building blocks for more realistic objects created with a computer. If you were on to construct a computer graphic representing each item below, what geometric solids or shapes would you begin with? For example, if you're going to create a computer graphic representing a building, which has a rectangular prism as the base, then add details represent the windows and other features. So what about a tree trunk? In the basic sense, I would just do a cylinder. An automobile. So maybe I'd have like a rectangle for the car, cylinders for the wheels. Yeah, pretty basic car. Rectangular prism, and then a cylinder. A hand. I guess like you can do a rectangular prism for that, and then cylinders for the fingers. An ice cream cone with a scoop of ice cream on top. I think that's a cone with the sphere. Shomo is second year studying the computer graphics. His first project will be constructed a 3D landscape which computer can play and write upon where sketchable geometric solids you see. I'll let you do this one on your own. There should be 1, 2, 3, 4. This is the base for that one. Below is a list of different geometric solids. For each one, brainstorm with your team possible items they can model with each base. So for me, I can make a house. I can make a ball. A square base pyramid. I guess you could do roof of a house. What can you come up with? Come up with your own. Thank you. For 15. Below is a photo of Nebraska farm. This landscape using geometric shapes and place of road objects. You create this landscape using geometric shapes. So what do you see? I see probably prisms, maybe pyramids and cylinders. Prisms. Prisms. They really like prism is like a prison and it's like off topic. Cylinders. The actor says pyramids, but I don't really see any pyramids on here. Alfred Hitchcock film North by Northwest, despite the mistaken idea that culminated the chase scene in Mount Rushmore. In the early stage of production, it is questionable if the movie would even be made because Hitchcock wanted to film the final scenes on the monument, and the National Park Service was worried about doing so would desecrate the park service serene China and democracy. At a point, it was shown that Hitchcock built his own Rushmore on the soundstage in Hollywood to explore this option. In tech crews created an aeroscope model that was 80.8% of the size of the actual model. The face on Mount Rushmore, 60 feet tall, is made of granite. Hitchcock's model will be made out of concrete. Choose your installed that represent Mount Rushmore. Estimate the amount of concrete in cubic inches that we need to create this model. The face. So on the face is 60 times 0.008, which equals 0.48 feet. So that's how high this is. 0.48 feet. Sorry. The face is 0.4 feet. Um, so I think I would draw a rectangular prism. And cylinder, hemisphere, sphere, hemisphere. This is 0.48 feet. And I think you can get probably 3 of them. So say this is 1.5. And this is probably double, so say 3 feet. No approximation. Not exactly sure. And by 1 foot. So 4 hemispheres. So 4 hemispheres, which is 2 spheres, plus the volume of a prism. So that's 1.5 times 3 times 1 plus 2 times pi 4 thirds pi times 0.24 squared. So 4 hemispheres. That's 4 times 1 half times a half sphere times 2 thirds the area of the base times the height. This is 4.5. .24 squared times 2 times 4 divided by 3 times pi. 0.48 cubic feet. So 0.48 cubic feet plus 4.5 plus 4.5. So 4.98. So 4.98 cubic feet. Use information below. How much in cubic information to compare the reasonable amount of concrete and cubic yards needed for each construction life instead of not much more. So you can do 4.98 divided by 0.008 cubed, which is approximately 303 million cubic yards if you're gonna do the real thing. 0.3. Here's your homework. PN now. Solve for x. So I'm gonna square this. Oh, add 1, so 5 minus x squared equals x minus 1 squared. 5 minus x equals x squared plus minus 2x plus 1. 0 equals x squared minus x minus 4. Is plus 3. So x plus 4, x minus 1 equals 0, x equals 4, and x equals negative 1, negative 4, and x equals 1. We aren't sure which one of those works, so square root of 5 minus plus 4 minus 1 equals negative 4. This 3 minus 1, which does not equal negative 4, so that doesn't work. And the other one is probably going to work, so 5 minus 1 square root, just 2 minus 1 equal 1, yes. So x equals 1. This is extraneous. So time divided by 3, 2x minus 4 absolute value, switch this line 12, and 12x minus 4 greater than 12, and then 12x minus 4 is less than negative 12, 16, 12x is greater than 16, x equals 16 over 12, greater than x is greater than 4/3, add 4, 12x is less than negative 8, x is less than negative 8 over 12. This is 5 squared times negative 3x plus 2, and this is 5 to the negative 4. So you said negative 6x plus negative 2 times negative 3x plus 2 equals negative 4. And then you solve. This how many times everything by 6x. So I have 5x minus 6 plus 2x equals 1. So I have 7x plus 7, x equals 1. Oh, and x equals what? Hold on your own. Oh, continue on back. Okay, this one's gross. Squared. So this is 7x plus 15. This is 5x plus 1 plus 4, and then plus 4 root 5x plus 1. Bring it in one side. 4 squared root 5x plus 1 equals 2x plus 11. If I can square everything again. 16 times 5x plus 1 equals 4x plus 44x plus 121. Then 80x plus 16 equals 0. 4x, no, 4x squared minus 44x minus 16, 15, 10, 105. That's just gross. This is a 10. And this is 100. And this is 20. Minus 16 is 86. And this is 40 minus 40. 86? 84 equals 0 divided by 4. X squared minus 10x. 22 plus 22. 21. So x minus 7, x minus 3, x equals 7, x equals 3. And you need to check them to see which one works. Great. 4-43. Forget about the next iPhone or tablet coming out any day now. The sweeping nation of is the cube, a small cube that is a phone, a speaker, a computer, a Wi-Fi hub, and just about everything you possibly need combined into a 1 by 1 by n cube. To charge, it sits on a charging base 1 by 2 by 2 by 12, which has no cord yet can charge the cube. The design of electronic is somewhat delicate. The company responsible for the cube has come yet to design an appropriate packaging system. They will be up to you to decide the type of shape of packaging, but they want to keep the cost of the packaging to a minimum. At the same time, the design and material of the packaging needs to be sturdy enough to protect the cube during shipping. The company believes that the suitable packaging can expect about 1% of the items will be damaged in shipping. One thing that sets this company apart from others is that the cube is made by a 3D printer, and they like packaging for the cube to be created on a 3D printer as well. The packaging design must be as forthing in itself while being aesthetically pleasing, trendy in terms of the company use. Our team's first research has found the following list of materials. For the 3D printer table shows the cost of material as well as the strength of the rating. The higher the number of the sharp material, the stronger the better packaging can resist damage. All 3D printing materials come in 3mm thickness, has 3mm in diameter, and purchased by the meter in length. That means, although the purchase film is by the meter, they not represent the volume because they come in thickness. Your task: design a packaging system that can be printed on a 3D printer Or will the human keep it safe and minimize the cost? The company or team will present your results in a report detailing the packaging system will look like, how strong you expect it to be, and the cost to produce a package system. All design is considered trendy. To convince the company that your package system can be printed, you must illustrate two different cross sections of the packaging system. The company has solicited the team for design so you can convince that your design is the best. Demonstrate your knowledge in all aspects of geometry and design. So essentially, I'm going to make a big rectangular or square box. That's a 12 by bases, 2 by 2 by 12. So this is 2 by 2. This is 1, 1, 1, 1. And this is 2 by 2 by 12. I'm gonna make a 13 by 12.5 by 12.5 square. And this one's like the base. So I'm gonna make this by 2 by 2.5, 2.2.5, and this is a 1.75. All of it can be constructed out of this because that's the most strong. It requires a total length of 25 inches. So if you add 2.25 times 8 plus 1.75 times 4, you get 2.25 times 8 plus 1.75 times 4, you get 25. So this is equal to 25 inches, which is about 0.635 meters. So 0.635 times 0.62 meters, which is about 0.40 cents or 40 cents. The panels can be made by acrylic or pomade, which we attach to the hollow frame. Attach the hollow frame so that the container has walls. The 4 panels measure by frame walls. So this is 2.25 times 1.75 times 4 plus 2.25 times 2.25 times 2, which is about inches, which end up being about 0.0653 millimeters squared. So the material is 0.3 millimeters wide. So if acrylic is used, it costs Sorry, the total area 2.25 times 1.75 times 4 plus 2 times 2.25 squared is 25 point that, and then you divide that by the number of feet by square meters. You end up getting a total of 0.01669. So I'm going to times that by 22 cents and then divide all that by 0.003, which gives us about $1.22. This puts a total of about $1.62. Students may want to choose fill that fits around the cube, but more protect the cube. Costing more to protect the cube, but open a variety of student responses. So mine's going to be just like a rectangle. Again, nothing too complicated, but open to interpretation. This is a weird problem. Here's your homework. And then let's go to the review. Half a liter bottle of Coca-Cola at a bottling plant. The equipment used to fill the bottle is not capable of distributing 500 milliliters each 5 bottles. So adjusting its amount, cola placed in bottles is normal distribution of 502 standard. What proportion of bottles would have more than 502? Because it's a normal distribution. 502 is the mean, so then 50%, because that's this 50%. What proportion of bottles between 500 and 502? So you're going to do norm, CDF, 500, 502, comma, 502, comma, 1.8. It's going to be really close to 34, but we'll see what it is. You're going to start using the Inspire app because for your test, it's the most helpful. I'm going to go to notes page, and if you go to this func f of x, hit this button here. That is the math box, and then I'm going to go to wrench, calculations, probability, distributions, normal CDF. My lower bound was 500, upper bound was 502, mean was 502, and the standard deviation was 1.8. Hit OK. Ooh, I was off. 36.7. 36.7%. Proportion of bottles are underfilled, meaning less than 500 milliliters. So because this and this add up, this whole thing adds up to 0.5. I could do 0.5 minus 0.367, which is about 0.133. What percentile corresponds to this number? So you're going to do norm CDF negative 9E999 comma 503 comma 502 comma 1.8, and that finds you the area to the left of 503, which is your percentile. Negative 9 E is right here, 999 503 under the 71st percentile. What percentile corresponds to 505? So we're going to 505, enter 95.2. So 95 percentile. I don't want to solve this one. So I'm going to square this and square this. We got 3t plus 1 equals 16 minus 8 square root 5. Minus t plus 5 minus t. I got 3t plus t, so 4t plus 5, 21 minus 20 equals negative 8 square root 5 minus t squared 16t squared minus 80, 160 t plus 400 equals 64 times 5 minus t, 64t added 64 is 80t squared minus, that's another 80 minus 3, 240t plus 400 equals 0 divided by 80t squared minus 30t minus 4, 5 equals 0. This doesn't factor very nicely. Just want to make sure. Y equals square root 3x plus 1. Y equals 4 minus 5 minus t. Yeah, give me a nice number. 21, negative 20, 4t squared, 64, negative 64 becomes positive 80, 64, 80, 4 times 20 times 2, 160. Was the 5, but adds the 4. This is 80 minus 64t. Add the 64t, you add it to this. Got it. So this is 16t squared, 64t added equals 96t and plus 320. 96 divided by 16, 6. So this is t squared minus 6t plus 20. One more twice the 20, but adds to 6. There's a mistake somewhere. Can't Strellos. Start over. I wish I could edit that out for you. So I have squared 3t plus 1 equals 16 minus 8 square root 5 minus t plus 5 minus t. Bring down to 16, that's negative 15. Bring down to 5 is negative 20. Add the 1, so that's 4t plus 20 minus 20 equals negative 8 square root 5 minus t. The square both sides is 16t squared plus 400 minus, that's 80 minus 160t equals 64 times 5 minus t. This is 80 minus 64t equals the same thing. Subtract 80, 320 plus add 64, which is negative 9, negative 160 plus 64, negative 96 t, 16t squared, equals 0. Dividing by 16, 96 divided by 16, I don't know, find this mistake and then put it in the comments, please. I'll come back to it. But don't worry about this one. I don't think it's on your test. I'm going to do a review now, but there are a lot of problems I said to skip. So just keep that in mind. So what are the 5 types of bias? There's question order, preface, 2 questions, and 1 bias wording, and desire to please. The question order is like the way you ask your questions, and the first question kind of leads into the second question, like dictates the second question, like how many do you play video games where you shoot people? Do you think violent video games cause tendencies? Preface is where like the first portion of the question gives you like some background information that leads to a certain answer. 2 questions is one where like there's 2 questions, but the second one is like you really have to say yes or you feel like a bad person. Um, Bias working using like very emotional words gives people certain responses. Desire to please that you actually want to please the um, you want to please the um, workers, like the, the experimenters. Go ahead and do this one, please, on your own. A block of wood measured 2 by 4 by 6, 2 holes drilled into the 4 by 6 to the 4 by 6 base of 2 inches diameter. Create the sculpture. Draw a figure. Compute the volume of the sculpture. I think you can skip this one. Skip. We did that last test. Skip. This one, given the graph, find the values A, B, and C. Well, the mean is 30, 25, and 35. But you can tell by that marker right there. Skip. Design experiment for the following statistical question. Does playing with a Rubik's Cube improve math scores? So you can get 60 students. And then you can randomly assign. So 30 Rubik's Cube, 30 no Rubik's Cube. And then you can test them. And then compare results. Ideally, to get those students, you can do a random sample, but odds are you probably can't do that. For the different cross sections for a cube, make a square, rectangle, triangle, hexagon, pentagon, equal, lateral triangle, scaling, triangle. Google it if you want to do it. What about a hemisphere? I think you can do a triangle, a circle, an ellipse, a parabola, and a half hyperbola. And these are just things that you should memorize. Draw normal distribution. Normal distribution for the mean of 20 and standard deviation of 4. Play with plus or minus standard deviation and approximate boundaries for the middle 64%. The underwhole curve is 1 or 100%. I think the 1 is not what you really want. And then if you like the stats, then you can take AB stats in 2 years. And then go plus or minus 4, 16, 8, 4, 24, 28, 32. And at the middle 64. So it's going to be 16 to 24. Determine the values by inspection. So it's 50 because that's half of it. Oh, we didn't have the bell curve. This is 1 goes from -9 to 9, infinity to infinity, and from 16 force is like 68%. And then this is 16 minus 4 minus 2 standard deviations. 2 standard deviations above and below, that's 95, approximately. Go ahead and type in the decimals or inspire and see what you get. A sample of 40 people were taken. How many minutes do you talk on the phone per day? Effect of a relative frequency. Table measures relative frequency. So bin of 1. That's most number 17. So 17 to 18, 18 to 19, 19 to 20, 20 to 21, 21 to 22, 22 to 23, and 23 to 24. Bracket, 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 bracket. Parentheses, 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 parentheses. So interval, and this is a freak. So that's 1, 1, 2, 4, 3, 2, 1. And the relative frequency, as you find the percentage, so you do 1 divided by 14, which equals 0.0714, and then 0.0714. That's double that, so 0.1428. That's double that, so 0.2856. Have that 0.2142, and then do 0.1428, and one is 0.0714. Make our relative frequency. Use some stickies. Seventeen, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I could cheat and do each one to be 0.714 and then go up, and then like nicely perfect, and it goes like up 1. But I think you're supposed to do it to like 0.5, 0.10, 0.15, 0.20, 0.25, 0.3. So this is like halfway in between. This is fairly close to here. 2.8, way up here. 2.1. Um, I went for There you go. Pretty normal. What interval has the second highest relative frequency? 21 and 22. What relative frequency? What is the relative frequency for that interval? 0.2142. What is the normal distribution? What would the normal distribution function be for this data? Draw the new histogram. So you can type in norm PDF x comma 20. Or you need to find the mean, which is 20.2143 comma 1.62569. So how do you do that? So we're gonna add a list spreadsheet. I'm gonna call this, what is it? Talk. And this is 18, 20, 17, 20, 20, 19, 21, 21, 21, 20, 23, 22, 19, and then 22. And then you can go up here, wrench, statistics, set calculations, one variable statistics, one list. The list is called talk, check, okay, and your mean is this, and your standard deviation is that. 18, 20, 17. There we go. So if I go to add graphs, norm, PD, you know how it comes like that in font? That means you typed it incorrectly. X, comma, 20.2143, comma, 1.62569, enter. And then it didn't show up, so you move it out, and then you see a small little bump. So you zoom that out. There it is. Hard to get. What percentage test scores fall between 19 and 23? Inspire, add, that's page, box, wrench, calculations, probability, distribution, normal CDF. Lower bound was 19 to 23, 19, 23, narrowed was 20.2143, and then this was 1.62569, enter. And then 13 point, so 11, 1.79. The next one is less than fall below 22. So then 22, 20.21, 43, 1.6, 25, 69. Okay, the last one is 19, 10, 9, 999, 20.21, 4, 3, 1.6, 25, 69, and then 0.77. Identify the biases. Obviously, intelligent people want to succeed. Do you prefer getting your math homework completed during seminar so you will not fail? So this is the preface. Two questions in one. Do you prefer getting your math homework completed during seminar so you don't fail? Two Q's in one. Obviously, bias wording. And then desire to please. You don't want to sound like you're a bad student. What do these commands do? So this is generate 7 random integers from 1 to 10. This generates 12 random integers from 30 to 40. This just makes a list. Create, store, list. Same thing, just using the store or the equals button. This see the calculator to generate random numbers. Check, 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 check. Draw an example of each distribution. Well, by model, skewed right, skewed left, normal with small standard deviation. It's very narrow. Normal with a large distribution like this. There's your chapter 2. You what has happened? Did you get all this? Did you miss this? So skip that. This was 25, 30, 35, because these are increments of 5. You have a random 60 students, you randomly assign them to 20, 30 Rubik's Cube, and 30 no Rubik's Cube, and then you test them on math, and you compare the results. Different shapes, you can Google it, but these are the different ones. Normal distribution right here. By looking at this, it's 51, 68, and 95, because that's just the rules. 95 is 2 standard deviations above or below. You made this interval. The brackets mean inclusive, and these mean a lot. So here's our frequency, here's our values, made the table, and then Yeah, I think you missed all this in the video. I'm really sorry. Test scores, and then obviously the biased wording. Two questions. One is the prefer getting math homework done during seminar, so you have to have two questions in one prefaces. The first part, so you don't want to succeed and desire to please. There you go. This is what you need to type in to get these values, norm CDF, and you can do that by going to wrench calculations. I think you can just type in norm CDF too. You type it in. Rand this is a random number generator between 1 and 10, 7 numbers. This is 12 numbers between 30 and 40. This stores the list 1. This is another way of storing it, but you say the list name first, and then the random C to calculate to generate random numbers. And you read this, and here's some different distributions, and then this is a normal distribution with a large standard deviation. So I'm going to do 5.12. I was working on a new function g of x. He writes the following steps: add 5, divide by 2, cube it, and multiply by 6. Write the equation. So, an equation for g of x. So, x plus 5 divided by 2 cubed times 6. So, you plug in 3. So, 3 plus 5 over 2 cubed times 6. That's 8. 4 cubed is 64. 64 times 6 is 384. What's the inverse? So now you do it backwards. So we have y equals x times x plus 5 over 2 cubed. So we switch it. So we have x equals 6 times y plus 5 over 2 cubed. Then you solve for y. Divide by 6. So x equals 6. No. X over 6 equals y plus 5 over 2 cubed. Cube root. So I have x over 6 cube root equals y plus 5 times 2 with y plus 5, and then minus 5, 2 cubed x over 6 minus 5 equals the inverse of x. Then you plug in 384 and you should get 3. And then you graph them both and see what you get. Find the inverse, so I'm going to switch. This is y equals 2, x plus 3 cubed. You switch them. So x equals 2, x plus 3 cubed. And divide by 2. Cube root. And then subtract 3. F inverse of x. This one. Y equals x cubed minus 5. So x equals y cubed minus 5. X plus 5 equals y cubed. Y equals the cube root x plus 5. Graph them, see how it works. Okay. Almost there, guys. I'll try not to mess up. Five point 1.2. Right, 515. Now, so you started the functions and working backwards to determine the equation of the inverses. Equals and functions inverses represent graphs. So this is what you discovered yesterday as a basis for completing the problem. So essentially, if you had the point f of x and the point f x y was on the graph, for f inverse of x, you switch them so y x is on the graph. So take these points and we'll plot them. So this is negative 5, 0. So I'm going to do 0, negative 5. And this is negative 4, 1. So I'm going to go 1, negative 4. This is 3, 0, 0, 3, 3, 0. And this one is 1, 2, 3, 4, 5, 6. Weird, that's a 6. That 5 is off. 3, 0. And then this is 2, 4. Go 4, 2. Sometimes you don't go through it perfectly. So then I just graph a parallel. And what I will tell you is this intersection point is on the line y equals x. So this point, weird graph, have 6, 0. So I'm going to go 0, 6, so 6, 0. And this one is 1, 2, 3, 4, 4, 6. So I'm going to go 6 down, negative 4. And this is 1, 2, 3, negative 3, negative 3, which is endpoint. And then this is negative 2, negative 6. So negative 6, negative 2. And there's your F. This one is, I'll let you do this one on your own. I'm going to check them to make sure you do them. Be careful about graphs where each function versus the same set of axis correspond. Look for a way to make the graph without determining the equation of the input first. So you can reflect over y equals x, or switch x and y to be y x. Oh, well. So switch input with output. So x becomes y and y becomes x. So 1, 2 becomes 2, 1. When you look at the graph of a function inverse, you can see the symmetrical relationship between the two graphs as well as symmetry. Draw a symmetry for each graph for the problem of 15. Does the equation look symmetric for each graph? Why do you think the line makes sense? Um, why does it look symmetric? Because when you switch x, y, When you switch x, y, the line y equals x is the same graph. Like a complete graph of x over 2 squared on a full sheet of paper. Use the same scale, and then think of the symmetry. Please put a like on this video and subscribe. So y equals x divided by 3 cubed squared. So we're 2 squared. And line y equals x. Then we just switch x and y, so x equals y divided by 2 squared. So if we fold this along this line, this portion will fold on this, and this part will fold on this. Okay, now I look at the ratio between the domain and range of the function's inverse. What are the domain and range of this? So the domain is all root numbers, and the range was y is greater than or equal to 0. What's the domain and range of the inverse? There's x is greater than or equal to 0, and then all row numbers. When you notice how the domain and range of the function are related, they're switched, but the variables go with it. For a graphing calculator, help with the inverse. Use the inverse drawing feature of your graphing calculator to verify the inverse for problem box 17 is correct. We did that. Correct. Identity equation of the inverse. So I have x equals y over 2 squared square root of x, but should be plus or minus equals y over 2, and y equals 2 times plus or minus the square root of x. But again, remember that that's not a function. So it says write down the equation of the inverse. So that's both of them, based on both of them. Consider the equation below. What is the inverse? How can you tell? Is it an inverse function? No. Fails. Vertical line test. Use color to trace the portion of the graph below from which x is greater than 0. when x is greater than 0 to this portion. And then the corresponding part will be this. Part B, restrict the domain for the function. And you can do x greater than 0. And you do comma. How do you restrict the domain on desmos? Oh, yeah. Then you would say y is greater than 0. And there you go. What is, that's just the y, that's the 2 times the square root of x. And then the other part, you switch it. That's the negative side. And this is the negative 2 square root of x. Consider the function below. Now can you restrict the domain so that the inverse will be a function? I think you want it to be, this is a parabola, 1, 2, 3 to the right. So I want just the, so you could do x is greater than or equal to 3, or x is less than or equal to 3. Graph the line, but this domain restricted, and graph the inverse on the same set of x. 1, 2, 3, like that. So it could look like that and that, or that and that. What's the equation of the inverse? So y equals x minus 30 squared, x equals y minus 30 squared. The square root of x plus or minus equals y minus 3 square root of x plus or minus 3 equals y. So g inverse of x equals 30 plus or minus square root of x. How can you determine them from the graphs which the inverse will be a function? Explain what are some examples of other functions whose inverses are not functions. You'd have to look, you kind of just, you can do not a vertical line test, but a horizontal line test. There's one, absolute value. Graph the function below and its inverse on the same axis. Label the graph and inverse with their equations. Let's see. Y. So x equals 1 plus 2 over y. So then I have x minus 1 equals 2 over y times by 2 over y. So I have y x minus y equals 2. Factor out of y. X minus 1 equals 2. So then y equals 2 over x minus 1. Really hard. This one's hard. Star. And then so y inverse is equal to 2 over x minus 1. Let's graph them. 2 divided by x minus 1, and then I think you can do x equals 2 divided by y minus 1. That gets you your graph. The domain looks like it's almost all our numbers, but it's not. So if you look at the graph, this green one gets really, really close to 0, and then this one gets really close to -1. And is the green one the original? Yeah. So f of x, the domain and the range, x is not equal to 1, and then y is not equal to 0. So then when you switch it, see x is not equal to 0, and x and y is not equal 1. This is your HW and your test. There's the review. So your HW is 4.4.2, 4.4.3, week 14 PDN, chapter 4 review, and 5.1.2. There's EC if you do the chapter for closure. And this is due 5-1. Almost there, y'all. Almost there. Thanks for watching the video, and see ya next week.